Hello physics students. In this video, you're going to learn how to analyze circuits that are more complicated than the circuits we studied in the last video, which were comprised of resistors that were either all in series or all in parallel. Today, the circuit's going to be made of parts that are in series and parts that are in parallel, all mixed together. And what we're going to have to do is calculate the current in different parts of the circuit, the voltage in different parts of the circuit, or maybe even the resistance in different parts of the circuit. Now, the techniques that we're going to be using are going to seem familiar because we've already analyzed combination circuits made of capacitors. But today, we're going to be applying those similar techniques to combination circuits made of resistors. Now, the circuit we're studying today is this one. And what we have to do is determine the voltage across this 3 ohm resistor and the current in this 5 ohm resistor. Now, the first point I want to make is that the voltage of this 3 ohm is not 12 volts, which is a common mistake a lot of students make. Remember, I've said this many times in this course, voltage is between 2 points, or in the case of an electrical appliance, it's between the 2 prongs that you plug into the outlet. So yes, this 3 ohm is connected to one side of 12 volts, but the other side of 12 volts is here. And so 12 volts is from here to here. This only gets apart like maybe 4 volts or something. We have to calculate it. Now, the general technique used in analyzing such a circuit is to look for parts that are in series and parallel and then keep simplifying the circuit through calculation until you get down to one single equivalent resistance of the entire circuit. Calculate the current and then backtrack through your analysis to figure out what you're asked for. So we look at the circuit and we look for a part to begin our analysis that's either in pure series or pure parallel. Now, some people might be thinking the 3, 4, and 6 are in series because they kind of look like they're hooked in a chain. But it's not true. In order for resistors to be truly in series, all of the current that passes through the first resistor must pass through the second and third one as well. But look here, we've got a wire junction right here, a connection. So let's suppose 2 amps comes through here. Maybe one goes here and one goes there. So the current here is 2 and 1 amps, so they're not in series because they don't have the same current going through them. Another thing that place people might look is maybe this 2 ohm and 6 ohm are in parallel because it kind of looks like they're in parallel. But in order for 2 resistors to be in parallel, they must have the same voltage across them, which is another way to say that the front ends of the resistors have to be connected through wires and the back ends have to be connected through wires also. And the front ends are connected with wires alone, but the back end of this resistor does not connect to the back end of this one because this 2 ohm is in the way. So these are truly not in parallel. They will not have the same voltage. The only way to begin here is with these two and realizing that they're in series. Every single electron that passes through one has to pass through the other. There's nowhere else for it to go. So what we'll do is we'll apply the series resistor rule to these 2 resistors right here. And so we just simply add them together to get 4 ohms. What we do is now redraw the circuit again with these 2 replaced by their equivalent of 4 ohm. And if we constructed this circuit from the beginning with just 1 4 ohm here instead of these 2, the battery wouldn't know the difference. So we're just kind of simplifying and making the circuit appear simpler and simpler until we get to that point where we just have 1 equivalent resistance. Now looking at this diagram, we could see that these are not in series again, but these 2 are in parallel, and these 2 are in parallel also. So why? Because the front end of this is connected to the front end of this with only wires, and the back end are connected with only wires. So these 2 are in parallel. And these 2, for the same reason, are also in parallel. So I will apply the parallel resistor rule to these 2 and these 2 right here. Oh, by the way, let me create a pause here to allow you to copy this part down so you don't get too far behind in the notes. Okay, so continuing on, the REQ here, adding them with the reciprocal rule, and you get 2.4 ohms right here, these two. And then for these two, with the parallel resistor rule, 1 over 4, 1 over 5, you get 2.2 ohms for right here. I use common denominators, 3 over 12, 2 over 12, gets 12 over 5 when you flip it over, 5 over 12 flipped over 12 over 5. But like I've always said, or in the last video, you could always just put this into your calculator carefully and get the answer by hitting the enter on your calculator. All right, so we have the equivalent of these two. So now we redraw the circuit. These two act like one single 2.2 ohm. These two act like one single 2.4 ohm. So we redraw that. And then we look and say, now we have a simple series circuit. So we can find the equivalent resistance by just adding all those together and getting 7.6 ohms. Now we can figure out, once we have the equivalent resistance of all these, so all of these together could be replaced by one 7.6 ohm resistor, and the battery wouldn't know the difference. So the current coming out of the battery then will be total volts over total resistance, 1.6 amps, using Ohm's law. Finally, we can get the voltage on the 3 ohm right here, because we know that the current out of the battery is 1.6 amps out here, which then means 1.6 goes here, 1.6 goes there, 1.6 goes there. They're in series, so 1.6 amps there. Resistance of 3 ohms gives us the voltage of 4.8 ohms. All right, so that's that part. I'll create a pause to let you catch up if you need it. Okay, now we got part A, finally. 4.8, not 12 volts, as I said in the beginning, because voltage is always two sides. So 4.8 volts. The final thing we need to determine is the current in this 5 ohm resistor. And so what we often have to do in this kind of combination circuit analysis is now to take our results and start working backwards. And what we could do is figure out the voltage between 2 points A and B. And what I'll do is I'll put them right here, A and B. And so I can use Ohm's law, V equals IR, which is Ohm's law solve for voltage. Put in the current, 1.6 amps out of the battery, which means 1.6 amp goes through there. And it's 2.2 ohm here, so the voltage here is 3.52 volts. Now, why did I do that? Because those 2 points on this diagram are right here. And if you would like, you could add those 2 points to this diagram as I have done here. And so I know it's 3.52 volts from here to here, which is also 3.52 volts from here to here because, you know, it's a parallel circuit here. So I know the voltage and the resistance here. I could find the current V over R, 0.7 amps. Okay, so let me create a pause to allow you to copy that down and catch up. Okay, so the maybe one final point. Let's suppose we wanted to find the current in the 4 ohm. What we could do is, instead of doing Ohm's law again, we could realize that in parallel, I total equals I1 plus I2. In other words, the total coming out of the battery into this point right here is, what was it, 1.6 amps right here. That's out of the battery. And then we figured out there's 0.7 amps down here. These are in parallel, so I in the 4 ohm, and we could figure that out and get 0.9 amps. So I just wanted to demonstrate one other way, you know, that there are multiple ways you could calculate multiple different things in a circuit. So I'll create another pause to allow you to copy that down. Okay, so that's it for today. We learned how to analyze circuits that are made of part series, part parallel, all mixed together. Again, the general technique is that you find parts that are either in series or either in parallel. You calculate the equivalent resistance of that one little piece, that one little component, redraw the circuit. Look for pieces that are series and parallel again. Redraw the circuit. Keep repeating that, and repeating that till you get down to one resistance. You could find the current out of the battery, and then you backtrack to find whatever else you need to figure out in the circuit. All right, so I hope you enjoyed the video. I'll see you in the next physics video.